Hi there. Uh, you're welcome in this section. That's my email address in case you may have any question. In this video, I will be working on trajectories and orthogonal trajectories. Okay. So remember that when we were dealing with from previous section, when we had to determine curvature, torsion, and all that is related to those two things, we were given a curve r. Given a curve r equals to r of t. Okay. And now remember when we had to go on our next step of on our route to determine curvature or torsion, we had to determine the r dt, right? Now we know that the r dt is a tangent, okay, this is g, tangent vector to r of t, okay? And then r of t is this vector here, okay? Now what we are given when we're dealing with trajectories is that we are given this as v of r. We are given the tangent vector to our curve, okay? Now we said that v, this vector here, it forms vector field in the region, okay? It's just a field. It forms vector fields within a region. A region can be like just this is a region, so it can be a circle or it can be whatever it can be, but it forms this vector field just like in physics. Remember that magnetic field lines, they are found in a region. So this definitely has to be a north pole, so this is gonna be a south pole, okay? So we see that this field lines here, they are formed within a region, okay? Now we fill the region with curves such that v of r is always tangent to the curve, and that curve is our r of t. So we say that we fill the region with a curve such that this vector is tangent to the curve r of t at any point r, okay? So this is what we actually do, okay? So we said that we have to determine the direction of this field, because they are vector field, right? So we need to determine the direction of those of that curve, okay? So to do that, we use v of r, which is our first derivative, to determine the direction, or to determine the orientation of the field by inserting arrows on their trajectories, okay? You may not get this clear, but you'll see once I do example, you'll get this clear and be able to know what I am talking about when I say that we insert arrows on the trajectory, okay? So I realized that I just used trajectory and then I've not really giving you what is trajectory. So when we take this v and then solve the differential equation of that, we actually gonna get r of t. So when you get that equation that we get after solving a differential equation is what is known as our trajectory. Okay, so that is what we do to find we just say to find the general trajectory. We have to solve the differential equation of the RDT is equals to V of R. We need to solve this differential equation. Now, one thing you must know is that V of R is given in terms of dx dt and dy dt. Okay, now to determine our trajectory, we actually have to solve the equation dy dx, okay, which is the same as saying dy dt multiplied by dt dx by chain rule. Note that this t is going to cancel out this t, and then you're going to remain with dy over dx. Okay, so note that what I am doing here, I'm just working with in this case I'm working with of sections in 2D. I'm just using 2D equations here, and then when we have something that is in 3D, we have to try to give x. You can give x in terms of either y or z, or vice versa, or x dot. You can represent it in terms of y dot or z dot. It will depend in the condition that you are given, but basically in 3D we're going to do example in 3D and in 2D so that you can get what I'm talking about clearly. Okay, now we go on to orthogonal trajectory. Okay, now with orthogonal trajectory, we will only be determining orthogonal trajectory in 2D. Okay, this is what we were told, because I don't know if, okay, to simplify matters for us, so we'll only be using be determining orthogonal trajectories in 2D. In 3D we will be having orthogonal planes, or okay, I'm not sure, but there is orthogonal, I don't know, they are not called trajectories though. I don't know if they are planes or whatever they are called. Okay, let's just focus on what we have to determine. Okay, now given that we have a vector v, we have a vector v of r. Okay, and this vector is given as v is equals to a function in g and a function in f. To determine the orthogonal trajectories, what we do is we solve for differential equation dy over dx is equals to minus g over f. Note that when we determine the trajectory, we solve for dy over the x, but when we determine the orthogonal trajectories, there is a negative sign in front of dy over dx. Okay, so okay, I think this is what you have to do, what you have to know about before going into solving tutorial questions or anything that is related to trajectories. Yeah, so check out the next video where we'll be doing examples on trajectories and everything that is related to them. Thank you for watching.